Good day once again, everyone, and we are back together just looking at calculus. Of course, you guys have been going on and on, just asking me to revise this section. Okay, so if you haven't subscribed, please just make sure you're part of the family. And please tell everyone that, hey, favorite uncle is doing the most when it comes to maths and science, right? All right, so let's get right into it so that we can get to the business of optimization. All right, so we're given there that f of x is x cubed plus 4x squared minus 7x minus 10. And by the way, this is from the May 2023 exam, right? So for those who are writing supplementary exams, some of you that were upgrading, this was the exam that they were writing. Right, so first of all, we're given a cubic function there, and they say to you, write down, right? Sorry about that. So that was supposed to read write down the y-intercept of f, right? And the fact that they say write it down, it means it's right in front of you. So remember, for the y-intercept, we're going to take x is equal to 0. And if we substitute x is equal to 0 for any of those, right? So this becomes 0, that becomes 0, that becomes 0. And so we are left with y is equal to negative 10. So your constant term always gives you the value of your y-intercept. So our y-intercept in this case will simply be, so our y-intercept will be y is equal to negative 10. Okay, so you can actually say that the coordinate of the y-intercept is 0 and negative 10. That's not what they asked for, but I'm just showing you there. Right, and then they say show that 2 is a root of the equation of f of x. I like it when they do this because they're actually giving you one of the roots, right? So in this case, what we're simply going to do is we're going to substitute x is equal to 2 and see if it gives us 0. Okay, so f of x, that is x cubed. This is plus 4x squared minus 7x minus 10, right? So let's say f of 2, okay? So that would mean this is 2 cubed plus 4 times 2 squared, okay, minus 7 times 2, minus 10. All right, so this will give us, that's 2 cubed, which is 8, plus 4 times, okay, let me write this nicely. This is 4 times 2 squared. Okay, so that's going to be 16 minus 14 minus 10. And of course, 8 plus 16, that will give us 24. Minus 14 minus 10, that's minus 24. And so that will give us 0. And you don't need to necessarily show the working out. You can just simply put that in your calculator. So from this step, you can put it in your calculator and prove that this is equal to 0, right? So in this case, it means that x is equal to 2 is a root of the equation. Right, so they say hence factorize f of x completely. Right, now please, this is the part that I want you guys to pay attention to. Okay, so we're going to say we know this is x cubed plus 4x squared minus 7x minus 10. Now we just found out that one of the roots, right, so this is equal to 0. So we just found out that one of the roots is x is equal to 2. But when we put that root there, we put it as x minus 2. Remember, in this case, when for it to be equal to 0, it's x minus 2, which is equal to 0, right? So now to factorize the rest of it, so we say this is going to be x squared, remember? So x multiplied by x squared will give us x cubed. And then for the last term, right, we say negative 2 multiplied by what number will give us negative 10. that will definitely be positive 5, right? So that number there would be positive 5. Now, again, we're going to now put this as bx, right? Because we want to know what that value for b is, right? And all that you simply do, ladies and gents, right? You just simply say, well, what are the x squared terms? So it's going to be negative 2x squared, okay? And then the other x squared term is x times bx squared. So this is plus bx squared, right? And so these two x squared terms must give you this one. So these must be equal to 4x squared. Right, so that means that minus 2 plus b should be equal to 4. You can just drop the x squared. So that's minus 2 plus b is equal to 4. So then it means that b is actually equal to 6. If we take that 2 to the other side, it becomes positive. So b is equal to 6, right? All right, so in this case, we've just found out this is equal to 6. Now, if you're looking at this and you're saying, hey, but what on earth is going on in this section? All right, it means you haven't watched our videos on calculus. Please have a look at that so that it could help you, right? Okay, so now that we found the value of b, okay, let's try and factorize this thing further, right? So we've got x minus 2, okay? Right, for this one, factors of 5 such that when I add them, give me 6. That's definitely 5 and 1. So that's going to be x plus 5, x plus 1, and this is equal to 0. And so we know that x is equal to 2, or x is negative 5, or x is negative 1. Right, so those are all our roots, okay? They said hence factorize it further. Right, ladies and gents, next one, 8.4. They say if it is further given that the coordinates of the turning points are those values over there, they say draw the sketch graph of f and label the intercepts and the turning point, right? So we're going to try and draw the sketch graph, okay, of this graph over here. All right, and I'm not going to make an attempt to have it as, as accurate as possible. I'm merely just trying to just draw the graph as much as I possibly can, right? So we've got a root at negative 5. We've got another one at negative 1, okay? And we've got another one at 2. Okay, so these are the roots. This is where the graph cuts through the y-axis, the x-axis rather. Okay, so these are the y-intercept axis, and these are the x-axis, right? All right, so now, because my value for a is positive, so I know that I'm looking at the shape of a graph that looks like this, right? For a greater than 0, right? So I know I'm going to look for my first turning point, okay, for my maximum value. All right, so it seems like the maximum is at minus 3. So it's this one here, minus 3.4. And all right, I'm just trying to annotate there. So that's minus 3.4 and 20.8. Okay. So that's negative 3.4. So it should be somewhere there. Okay. So that's negative 3.4 somewhere there, and 20.8. So that's where our maximum is. Okay, and the next one would be where we've got 0.7 and negative 12.6. Okay, so negative 0.7, let's say somewhere there, and negative 12.6. Okay, as I said, I will make no attempt. All right, so 0.7, okay, and negative 12.6. I'm not going to make an attempt to make this graph accurate, right? But in this case, it must just be a depiction of what is happening. And we know that our y value is, or our y-intercept is at negative 10, right? Okay, so there goes our graph. We know this is a maximum, okay, and it should pass through there, pass through there. Okay, so this is our minimum. Okay, so there's what our graph should in fact look like. Okay, so we know it passes through negative 10 over there. That's our y-intercept. Okay, right, I hope that makes sense, ladies and gents. Right, as we move on to the next question. Okay, so what I'm going to do is that I'm going to I've just repeated that question over there so that we don't keep scrolling up. They say use the graph to determine the values of x for which f prime x, okay, so meaning where the derivative is less than 0. Now remember, ladies and gents, when we are talking about the derivative, right, we are talking in this case about the gradient of the graph, right? So where is our gradient less than 0? So you can see the gradient of the graph is increasing over here. So our graph has an increasing gradient. So our gradient is positive over there, right? It's also positive all the way over there. So we've got a positive gradient. So where is it negative? So we've got negative gradient, right, from that turning point there up until we get to the other turning point. Okay, so in giving the answer there, we're going to say, well, so that's 8.5.1, right? So 8.5.1, we say, well, it is negative, gradient is negative, where x is an element of negative 3.4. So from the x value of this turning point, negative 3.4, and we don't include that value because they only said where the gradient is less than 0, not less than or equal to, right? At the turning point, the gradient is 0, right? And then all the way until the next turning point, which is 0.7 for x less than 0.7, so that is that value there. So, or you can write this as x less than 0.7 and greater than negative 3.4. Right, I hope that makes sense, ladies and gents. Right. Okay, so yeah, let's take this one here. They say to us where for which values of x is the gradient of a tangent, right, of f will be at a minimum, right? So the gradient of a tangent, right? So in this case, remember, a tangent is a line that touches the graph once, right? So where will we have a minimum gradient in this case? So I want you to note, so what we know is that we're going to have, the gradient, of course, it's positive all the way, right? So we know that the gradient is actually 0 over there, right, at the turning point, right? And of course, we know that then it becomes negative, okay? So it's actually, the gradient becomes negative, or rather a minimum, in this case, at the point of inflection, okay? Because that's when, again, it starts, changing again, right? So the point of inflection, ladies and gents, what we can do is, just to make it simple, it is the midpoint between your two turning points, right? X values of your turning points, right? So in this case, where, all right, so 8.5.2, okay, so I'm going to take my values for the turning point. Okay, so I'm going to say, well, it's going to be at 0.7 plus a negative 3.4, right, divided by 2. So that's the midpoint. So in this case, I'm going to have minus 3.4 plus 0.7. Okay, so that's minus 3.4 plus 0.7. Okay, so that gives me negative 2.7, and that divided by 2, I get x is equal to negative 1.35. All right, so I hope that makes sense, ladies and gents. So that is where we will have the gradient being at a minimum. Okay, right. So, and then the next one. Now, this one just needs a little bit of an understanding of what we're doing, right? I want you to please listen carefully. So they say where f dash x, now remember f dash x represents the gradient, right? So the gradient multiplied by the derivative of the derivative, right? In this case, I'm going to explain this, okay? Being less than 0. Now, please, I want us to note, what does less than 0 mean? It means it becomes negative, right? So when do we have a negative? So we could have a negative when this guy is positive and this one is negative. We're going to talk about that just now, right? Now, let's talk about the first scenario, right? So where the gradient is positive, right? So we want where the gradient, so where this graph is an increasing function, right? But what does this mean, right? F double dash. Remember, that represents, in this case, the concavity of the graph, right? We said when f double dash is less than 0, right? So it's negative, right? This is where the graph is concave down. Okay, so concave down. Now, we want where the graph is concave down, right? And it is an increasing function. Right, now let's go back to the graph. Where the graph is concave down, so that's before that point of inflection. We said our point of inflection was at negative 1.35. So that's somewhere. Yeah, I erased that by mistake. Okay, so at negative 1.35, which is this value here. So we know the graph is concave down over here, right? But where is it an increasing function and concave down? So I'm sure you can already see where our solution is, right? So it is an increasing function all the way up until here. And in this case, it is also concave down. So for x, element of negative infinity up until we get to that turning point there, it is both concave down as well as an increasing function. The gradient is positive, right? So for the first one, we're saying where x is an element of negative infinity. Now, please, I want you to note, right, all the way up until the first turning point, and our first turning point was at negative 3.4. And we're going to include that value because they said less than or equal to. So all the way to 3.4, which is included, right? Now, remember, for a graph, for anything to be negative, right? Now we're going to consider the next permutation, right, where we've got this guy being negative and that guy being positive. So what does that mean? Where the graph is a decreasing function, right, it's decreasing, but it is concave up. Okay, concave up. All right, so now where the graph is a decreasing function, but it is concave up. Now let's go back to the graph. Decreasing function, so it means from that point of inflection, right, it starts being concave up, but it is both a decreasing function over there and it is concave up. Okay, so it's decreasing there. Remember, after this turning point, it becomes an increasing function again. So in this case, it means from that point of inflection, which is negative 1.35, right, all the way up until our turning point, which is 0.7. So our next point is where x is negative 1.35, which is our point of inflection, right, as well as, in this case, 0.7 at that turning point, and we're including those values because in both those instances, the product would be equal to 0. Right, so I hope that makes sense, ladies and gents. Right, so remember, when they say less than, we mean that it's negative. So remember, positive times a negative, okay, will give us a negative. A negative times a positive gives us a negative, and that is how we're able to interpret that. All right, I hope that makes sense, ladies and gents. All right, and we are going for optimization for the next one. I hope that your preparation is going well. I'll see you guys next time. Sharp, sharp.